Welcome! I am Teacher M. This math tutorial video is focused on limit properties with factoring. If you are interested to learn more about this topic, stay and watch the entire video. The previous 8 videos are focused on the limit properties such as constant, identity, scalar, sum and difference, product, quotient, power, and radical property of limit. This video is focused on additional practices to these limit properties and on what to do if you encounter an undefined result after directly applying limit properties. Before you proceed on this video, I highly recommend to understand first the limit properties. You may watch it using the links in the description below. Let's do some example. First example. The limit of the quotient of the difference of x squared and 4 and the difference of x and 2 as x approaches 2. I highly encourage you to pause this video and find the limit of a function. Let's proceed. Apply quotient property. We have the limit of the numerator and the limit of the denominator. Next, apply sum and difference property to numerator and denominator. We have the limit of x squared as x approaches 2, subtracted it to the limit of 4 as x approaches 2, over limit of x as x approaches 2, subtracted it to the limit of 2 as x approaches 2. To continue, we have the square of the limit of x as x approaches 2 using the power property, and rewrite the remaining terms. Then, limit of x as x approaches 2 is 2. Using identity property, subtracted it to the limit of 4 as x approaches 4 is 4. Using constant property, over the limit of x as x approaches 2 is 2. Using identity property, also subtracted it to the limit of 2 as x approaches 2, which is 2. Using the constant property. Simplify. Square of 2 is 4. Let's rewrite the remaining terms. Simplify it further by getting the difference of 4 and 4 is 0. Over the difference of 2 and 2 is also 0. Observe that the result is undefined when you apply the limit directly. Does it mean that the limit is undefined? To answer this, let's observe the function using its graph. The graph of the function is a linear function with a hollow point at x is equal to 2. This is telling us that the function is undefined at x is equal to 2. I encourage you to pause this video and observe where the function is approaching 2 when its x is approaching 2 from either side. Or what is the limit of the function as x approaches 2? As you can see, the function is approaching 4 from the left and right side. Since the function is approaching the same number from the left and right side, we can conclude that the limit is existing. And the limit of the function as x approaches 2 is 4. The question there is, how can we find the limit using the limit property? To address this concern, there are ways to find the limit using limit properties. Before applying the limit properties, either factorization or rationalization can be applied first. Observe that the numerator is factorable. Pause this video and try to find the factors of the difference of the square of x and 4. The factors of the numerator are the sum of x and 2 and the difference of x and 2. Rewrite the denominator. It is clear now that the difference of x and 2 can be divided by the denominator, which has the quotient of 1. 1 multiplied to the remaining factor. The result is the factor itself, which is the sum of x and 2. By applying limit properties, we have the sum of the limit of x as x approaches 2 and the limit of 2 as x approaches 2. Using the sum and difference property, limit of x as x approaches 2 is 2 using identity property, and added it to the limit of 2 as x approaches 2 is 2 using constant property. Then get the sum, which is 4. Thus, the limit of the function as x approaches 2 is 4. Another example, what is the limit of the quotient of x squared plus x minus 6 and x plus 3 as x approaches negative 3? Again, I encourage you to pause this video and try to find the limit. To continue, apply the limit property. Take the limit of the numerator and denominator using quotient property. Next, take the limit of the numerator and denominator using sum and difference property. It results to the limit of x squared as x approaches negative 3 plus the limit of x as x approaches negative 3 minus the limit of x as x approaches negative 3 over the limit of x as x approaches negative 3 added to the limit of 3 as x approaches negative 3. Then, take the limit of the square of x using power property, which makes it as the square of the limit of x as x approaches negative 3, and rewrite the remaining terms. Take the limit of x as x approaches negative 3 inside of the second power, which is negative 3, using the identity property. Added it to the limit of x as x approaches negative 3 is also negative 3, using identity property. And subtracted it to the limit of 6 as x approaches negative 3 is 6, using constant property, over the limit of x as x approaches negative 3 is negative 3, using again the identity property. Added to the limit of 3 as x approaches negative 3 is 3, using constant property. Simplify. Square of negative 3 is 9, added to the difference of negative 3 and 6, which is negative 9, over the whole denominator. Simplify it further. The sum of 9 and negative 9 is 0, over the sum of negative 3 and 3 is also 0. Based on the solution, the result is also undefined. Similar to the first example, let's observe its graph. Observe that the function is aligned with the hollow point at x is equal to negative 3. This means that the function is undefined at x is equal to negative 3. Pause this video and observe what is the limit of the function as x approaches negative 3, or what's the number that the function is approaching to when its x is approaching negative 3. The graph is clearly showing us that the limit of the function from the left and from the right of the function is negative 5. Like in the first example, let's apply factoring first before applying limit properties. Observe that the numerator is factorable. Pause this video and try to find the factors of the numerator. Let's proceed. The factors of the numerator are the difference of x and 2 and the sum of x and 3 over the entire denominator. The factor of the sum of x and 3 of the numerator can now be divided by the denominator. Get the quotient, which is 1, and multiply it to the remaining factor, which is the difference of x and 2. Then, the product is the difference of x and 2. Then, take the limit using the sum and difference property. We have the limit of x as x approaches negative 3, subtracted it to the limit of 2 as x approaches negative 3. Next, limit of x as x approaches negative 3 is negative 3 and subtracted it to the limit of 2 as x approaches negative 3 is 2, using identity and constant property respectively. And get the difference of negative 3 and 2, which is negative 5. Thus, the limit of the function as x approaches negative 3 is negative 5. There you have it. How to deal with undefined result when you directly apply limit properties. Remember, if the function is undefined at a certain value of x, it signifies you that you need to do something else. Either you do factoring or rationalizing before you apply the limit properties. If you learned on this video, hit the like button and subscribe to be updated and notified for other math lessons. See you!